Good morning, class. This is the first set of problems from the solutions worksheet. These are the problems labeled general properties of solutions, and again, only the problems, not the concept questions, are included. In the first problem, we're asked which diagram best represents the hydration of sodium chloride when dissolved in water. They give us a helpful hint here that the chloride ion is larger in size than the sodium ion, and they ask us to explain our rationale. So we'll start with the structure of each substance. The structure of water includes oxygen and hydrogen, and because oxygen is significantly more electronegative, it also means that the oxygen is partially negative in charge and the hydrogens are partially positive. Looking at the structure of sodium chloride, it doesn't just dissolve in water, it dissociates into sodium ions and chloride ions. So we could eliminate answer choice A right off the bat because it shows sodium chloride existing as molecules, not as individual ions. That leaves us with choice B and C. If we use their hint to label the ions, the smaller ones are sodium, the larger ones are chloride, and we could do that for each diagram. Next, we look at the orientation of the water molecules. All of the water molecules should be orientated so that the opposite charges are aligned to the ions. Therefore, the oxygen side of the water molecule should be pointed towards the sodium ion. The hydrogen side of the molecule should be oriented towards the chloride ion. In choice B, we don't have that. We have hydrogen pointing towards sodium, positive towards positive, and oxygen pointed towards chlorine, negative pointed towards negative. That doesn't work. So our correct answer is choice C, which identifies the sodium ions as being surrounded by the oxygen side of water, and the chloride ions are surrounded by the hydrogen side of water. In problem 2, we're asked to identify whether each substance is a strong electrolyte, a weak electrolyte, or a non-electrolyte. Water is considered a very weak electrolyte, as we discussed in class, and potassium chloride would be a strong electrolyte. The reason why is it's highly soluble in water. You have a group 1 metal bonded to a halogen. In the next one, we have nitric acid, which is one of our strong acids. So it is a strong electrolyte. It breaks down into hydrogen ions and nitrate ions. And remember, the hydrogen ions will bond to water to become hydronium. In choice D, we have a weak electrolyte or a weak acid. This is acetic acid, which the hydrogen at the end will ionize. And then in letter E, we have a non-electrolyte. This is sucrose. It's a molecule that does not ionize in water. Letter F, barium nitrate, is a strong electrolyte. Remember, anything with nitrates, highly soluble. In letter G, we have neon, which is a non-electrolyte. It's a noble gas. It's not going to ionize. Letter H is ammonia, which is a weak electrolyte, and more specifically, a weak base. And letter I is a strong electrolyte or a strong base. This sodium hydroxide dissociates easily because it has a group 1 metal. Okay, in question 3, we're asked to identify how electricity is passed through an electrolytic solution. Is it caused by the movement of electrons, positive ions, negative ions, or both? We could eliminate choice A. It is not electrons only. We discussed how electricity passes through a solution in the form of ions, not like electrons flowing through a circuit. So amongst our choices, the correct one is letter D. The reason why? Solutions are neutral. So any flow of cations must be balanced by a flow of anions to maintain neutrality. And the last one, number 4, explain why a solution of hydrogen chloride in benzene does not conduct electricity, but in water it does. Again, we look at the structure of each substance. Benzene is a nonpolar molecule. Water is a polar molecule. When hydrogen chloride is placed in benzene, there are no partial charges on benzene to cause hydrogen chloride to ionize. But when placed near water, it will ionize because it is a polar molecule. So what that means is the negative side of water, which is the oxygen, will attract the hydrogen side of hydrogen chloride, breaking it into ions, and the hydrogen side will attract the chlorine. Once it's broken down, the hydrogen will actually bond to the water to create hydronium ions.